Okay, so again, moving on to some more topics that are going to be beneficial for you. This topic here, if you want to work on this as we go, that is the name of it. It's understanding the distributive property. And with the distributive property, what we're trying to see here is, can the distributive property be used with this problem here? So it's 6 times parentheses 6 plus 9, or the quantity 6 plus 9. And when you see this, just so you guys don't get confused, right? They use the multiplication symbol there for that. But when we write it as students or as instructors, when we're writing this, we typically write it this way, because the parentheses does work as a product, correct? So now when we're doing the let me mute people. When we distribute here, what's going to happen is that number outside of the parentheses is going to multiply with each number inside of the parentheses individually, correct? So I'm going to get 6 times 6 plus 6 times 9. And how that happened, just so you guys can see, this 6 is going to multiply with this 6, and then that 6 is going to distribute and also multiply with the 9. Oops. So, can we distribute? Clearly the answer is yes. And then it's going to ask us if we can fill it out, what does that look like? And this is what it looks like. So this answer is this piece here, right? And then if we wanted to finish it, because we should want to finish it, 6 times 6 is 36. 6 times 9 is 54. And I believe that that's 90. Okay, now one of the questions that might come up is, why is it asking, can we distribute? And here's why it's asking that question, because it's important. The distribution product is it's a product, right? So if we don't have a product, we cannot do distribution. So here is one that you cannot distribute. So if I had gone 6 plus parentheses 6 plus 9, this is not something that can be distributed. And the reason that it can't be distributed is because it's not a product. Okay, so in this example, if we were going to use properties, we could move the parentheses. That would be the associative property. Or we could add it the way it is, but there is no distribution here. It's significantly different. So looking at this problem, I would have gone 6 plus 15, and then that would have been 21. So here, just so you know, it cannot distribute. Does that make sense? Okay, this should be a topic that's going to be quick for you guys. It should be one that it's going to help you guys get through your topics quickly and manage. My recommendation is, as you guys look at this, hop on and look to see how to find these problems, these specific topics, so that you can work on these specific topics. Okay? All right, let's go to the next example. And the next one talks about identifying solutions to an equation in one variable, and this is a 2-step equation. So what's going to end up happening here is they're asking us to find if they are solutions. So if they are solutions to this problem here, given that our y would be 5, -6, -2, and 4. So we're going to have to check each one of these. Okay? So let's go through it. My advice is I would not do the distribution property. All I would do was substitute in. So 9 y minus 6 is equal to a negative 9. For this first one, I would go 9. 5 minus 6 is equal to negative 9. And I'm trying to confirm that, right? I'm trying to check to see if that in fact is true. So 5 minus 6 is what? What do you guys think?
-1.
Yeah, it's negative 1. So I'm going to get 9 negative 1. Is that equal to a negative 9? We know that 9 times negative 1 is negative 9, and so we see, I should draw arrows, that it in fact works. So this would be a big fat yes. Does that make sense? All right. So then for the next one, we would again have to check that, and we'd go, all right, 9 negative 6. Let me fix that. That bugs me. Negative 6 minus 6, is that equal to negative 9? Well, pretty quickly we can tell that this one is not going to work, right? Because I'm going to get 9 times a negative 12, and that's a big number, right? What is that, a negative 108? So we see that we get a negative 108 and negative 9. That's not equal, and so this one here would be no. And this is the process of this problem. So you can see the difference between the previous topic and this topic. Some topics are going to be quick, right? You find those and you're like, thank the Lord, I'm going to finish my homework. And then you have some topics like this where it just takes a little bit more time. But it's okay. Just make sure you just keep grinding at it. Then 9 and a negative 2 minus 6, is that equal to a negative 9? We see that we're going to get 9 times a negative 8. And at this point, we know that's not going to work, right? Because that's going to be a negative 72, and negative 72 is not negative 9. And so again, this one would be a no, right? 9 times 4, what do we know about 9 times 4? 9 times 4 is 36. Is that negative 9? The answer is no. Make sense? So as you start seeing this and getting more comfortable, you're going to be able to see, okay, I don't need to show all this work. The only reason that I'm showing the work is because I'm trying to demonstrate it for you. But if you can see it just by plugging in, by all means do that. So sometimes a lot of people will think, oh, one's yes, the other's going to be no. Alex is tricky. Sometimes they'll change it and it'll be 2 and 2 or 3 and 1 the other way. So you don't have to do more problems. Just do all the steps for all of them so that you can feel comfortable and feel successful with this, okay? All right, any problems with this one? Pretty straightforward, right? Okay, and again, this is the topic. So I want to make sure that you guys know what topic it is so that you can address it and get it done. Have you guys noticed how I do your homework for the topics? How at the beginning of the week, is it 10 or 15 topics?
10.
It's 10. And then for the weekend, I believe it's 25, right? Because I give you the whole weekend to be able to do things. So 35 topics in a week, that should take quite a significant amount of time. And so that's to allow you to get the hours in, right? Because remember, the hours that are required are 10% of your grade. So that's kind of the way that I really am getting on the attendance side of it. And I'm making attendance 10% of your grade. And I do that by the hours that you're spending on Alex. Okay? I'm going to send some emails out at the end of this week so that you all know where you stand in terms of total hours. You should be at least 16 hours. after these 2 weeks, right? So if you're under that, just know that you're losing percentage points for participation, okay? So I'll send those emails out just so you guys know. Would you prefer, even though I showed you guys last time how you could see where you're at in terms of hours on Alex, correct? Would you prefer for me to do that weekly for you guys? Or are you guys okay just seeing that on Alex? It's okay? All right. I just want to make sure because there are some people I worry about who, the lack of participation could be damaging, and I want to know what's going on. Okay? All right. Let's do the next one. So this is identifying properties used to solve a linear equation. And so the linear equation that they're giving us is this one right here. And so let's see if you guys can help me do this. From here to here, what happened?
Division.
It's division, right? They divided by that -8. So if that's the division that's occurred, what's the property name that does that?
Equality.
What's that? I'm sorry, Nicholas?
Division property of equality.
Perfect. So this here would be the division property of equality. And the reason it's equality is because we have an equal sign. Eventually they'll have these division properties of inequalities when they're not equal signs. Okay? But perfect. What's happening from that step to the next? From here to here?
Simplifying.
Perfect. So this is going to be simplify. All right, and the next?
Addition property of equality.
Good. And lastly, you guys got it, right? It's simplify. Now, what does this tell you that I've covered this for 2 days now? Do you think it's a big deal? If I'm spending time on it, it's something that's going to become imperative that you guys understand. Because what's going to end up happening is I'm going to give you a problem where I'm going to go, all right, what's 2 times x minus 3 equal to, I don't know, 17? And you're eventually going to have to solve that problem doing all of the steps, right? Without it being worked out and telling me what the properties are. The point of doing the properties first is that you understand what's happening, right? So in this problem here, what would we do? Oh, and in fact, let me make it simpler. What would we do?
Distribute.
We could distribute. That's a good way to do it. A way to save us some work is to divide by 2, though. Because if we divide by 2, don't we just get 9 on the other side? Which makes the problem cleaner. Do you see that? So, in fact, I'll show you both ways. So if I do it with distribution, I would have gone 2x minus 6 is equal to 18, right? Then I'd have to add 6 to both sides, correct? So if I add 6 to both sides, I would have gone 2x minus 6 plus 6 is equal to 18 plus 6, addition property of equality. Then I'd get 2x is equal to 24, simplification, and then 2x divided by 2 is equal to 24 divided by 2, division property, and that would have equaled x is equal to 12, right? So perfectly fine. Now, if I do it the other way, if I would have gone 2x minus 3 is equal to 18, if I go ahead and divide by 2, I'm going to get x minus 3 is equal to 9. And you see, it's a little bit less work, right? Just a little bit. So I'm going to go x minus 3 plus 3 is equal to 9 plus 3. So x is equal to 12. That is the same as that. So I used to tell my students, especially when I taught high school, I'd be like, hey guys, I can do this problem like 7 different ways. And they're like, no way. And I'm like, okay, watch this. And so there's multiple avenues that you can take to do these problems. The goal is to get to the point where you can do all of them, but then you can see which one's the most efficient, right? Because one thing about mathematicians that I'll tell you, we're extremely lazy. We want to get to the answer as quickly as possible. And so because we want to do that, we strive to learn the material that we're doing super well so that we can get there quickly. A lot of people don't like to work that hard to know something, and so it makes math difficult, right? It's the one subject that demands you understand. It's but I love it. It's puzzles for me. Okay, this next one, very similar to the one we just did, and I want you guys to do it, and then I'll write it down. So I'll give you guys just a little bit. I want you guys to try it, and then I will do it. Okay?
Do you want us to do it that way, the division property, or can we do it?
So what I want you to do is tell me what properties are being used, the steps that are used to solve the problem. Does that make sense? And then what I'll do is I'll give you guys a couple problems to do and see if you guys can solve to get to solving the problems. I'll do some examples with you guys. Okay? I'll give you guys one more minute and then I'll do it, okay? All right, so you guys can see with this problem, they've done it in a different way than the previous problem, correct? In the previous problem, they divided by the number in front of the parentheses, right? And in this case, that's not what happened. What we end up seeing is we have a negative 8 here. So we got to think negative 8 and 28. How did they get that? Well, doesn't it look like 4 times the negative 2 is going to give me that negative 8? And 4 times that 7 is going to give me that 28. So what this ends up looking like is that this is the distributive property. Right? And again, of equality, but we know that because there's an equal sign. So be careful and with these problems as you do them. Then the step below that, it looks like what they're doing here is they're adding 28 to each side. right? And since they're adding 28 to each side, you see that this is the additive property, or the addition property, however you want to call it. The next step looks like it was simplification. And then here, it looks like what they're doing is they're dividing by that -8. And so what we get is the division property. And then lastly, it's simplified. Does that make sense? We're okay with that? All right. These rules are important. When I've taught Math 33, not using a program like Alex, this was something that I spent a lot of time on because it's a building block that becomes so very important to solving these problems later. Let me give you a couple of problems that I want you guys to try to solve, seeing if you understand these properties. Now, you don't have to write the properties. I'm going to have you do it kind of like I did this problem here, okay? Where you guys are going to go through that process, and I just want to see if you guys can solve them, all right? So maybe we'll do two or three, depending on how you feel, and then I'll answer questions for you guys on any questions you might have in terms of the math that you're doing. Okay? All right. So how about this? Try these two. Now, I don't want you to give me the answers. Just let me know when you're ready. Okay? Do you guys want me to talk about them? Okay, let me give you just a quick hint. So remember in the first problem that we did that was like this, we divided instead of distributing, right? In this problem, should I distribute or divide? What do you guys think?
That's divided.
Divide. Now, it's interesting. In this problem, it's perfectly fine to divide. Why?
Because you can divide the 5 to both sides.
That's right. The 5 will go evenly into the 80. Here, should I divide by the 4?
Yeah.
I can, but I'm going to end up with a fraction or I'm going to end up with a decimal. And so we kind of want to, if we're going to have a fraction or a decimal, we want to get to that at the end so we don't have to deal with kind of what we say are ugly numbers, right? So this one would be perfectly to divide first. This one here I would distribute first. So I'm trying to teach you guys techniques on how to decide whether you should divide or distribute, okay? And that's the distinction between the two. The number in front of the parentheses, looking at the other side, does it go into it evenly? If it does, perfectly fine to divide. If it doesn't, you should distribute. Make sense? Okay. So in this problem, I'll divide. So I'm going to get 5x plus 7 divided by 5 is equal to 80 divided by 5. So I'm going to get x plus 7 is equal to, is that 16? Right? Then I'm going to go x plus 7 minus 7 is equal to 16 minus 7. And so x is going to be equal to, I believe that's 9. Right? And then one of the things that I always want to do, and this is where typically students end up having a problem. They don't want to check, right? Because it's like, I got the answer, I don't care. But you should care, because you should check to see that your answer is correct. So then you should check. And so the way to check would just be to go 5, 9 plus 7, right? Because I'm going in place of the x in this case. What's 5 plus, what's 9 plus 7?
16.
That's 16. And that is, in fact, 80. And so here, what do I know by doing the check? I know 100% that I'm right. You know, when I was a college student, I would leave exams and my friends would ask me, hey, how do you think you did on the exam? And I'd be like, what do you mean think? Like, I know what I got right. I know the ones I got wrong. Because when I checked them, I could confirm that I had the right answer. The ones that I couldn't confirm, I was most likely wrong on. So I always, when I took exams, I would check my work to make sure I was right. At this level, through calculus, you probably should check your work. But a lot of people don't want to do that. They just want to hammer through and be like, I'm done, let me get the heck out of here. Right? How many of you, and be honest with me, have gone into an exam and been like, heck yeah, it's an exam day. I'm going to finish quick so I can get out of school early. I did it. I know it. It's like, hell yeah, today I got time. I can go to the beach. So I didn't realize that I was harming myself by that. And so take your time. Check your work. Because what ends up happening, and true story, I had a class where I did that quite a bit. I ended up having to take the class again. So I thought I was saving myself time. I had to add a semester to my college time because I was rushing. Isn't that silly? I rushed so that I'd have to stay there. But we all have to go through our experiences and learn. But it's some advice that I'd give you as someone who did that a lot. Like, yes, the class is 2.5 hours, but I can be done in an hour and 30 minutes. And I have time to check, but nope. I want to go hang out with my friends. Silly. But, oh well. Stuff we do. Okay, so the next problem, it's a different method to attack it. And so what I'm going to do is I'm going to distribute, right? So I'm going to go negative 4 times 3x. That's going to give me a negative 12x. And then I'm going to go negative 4 times 2, and it's a positive 2, so I'm going to end up with a minus 8. Right? Oh, I shouldn't. It's going to be a fraction, this one. It's going to be ugly. And that's going to be equal to 14. Now, what I'm going to do is I'm going to demonstrate my steps. So I'm going to go negative 12 minus 8 plus 8 is equal to 14 plus 8. That's going to give me a negative 12x is equal to, what is that, 22? Now when I divide by the 12, I'm going to divide by negative 12. I'm going to get x is equal to, and then there's a negative sign there. What can I do to this 22 over 12? Is there a number that goes into both?
Simplify it.
Yeah, we got to simplify it, right? So how can we simplify this problem? What goes into 22 and into 12?
Two.
It's 2, right? 2 is the number that goes into both. Since 2 is in the ones digit for both of them, we know that 2 will work. And so I'm sure a lot of you guys always try to find the biggest number that go into things. You want to know what I do? I always try to find the smallest number. Because I know I can break it down and keep breaking it down that way. And then what it leads to is prime factorization, which is something that ends up being very helpful. But so I'm going to get, how many times does 2 go into 22? It's 11. How many times does it go into 12? 6. And so this would be my answer. Now, most of the problems that you're going to have aren't going to have fractional answers, but I wanted to show you one that was like that, because how many of you guys got to the point where you were here and you were just kind of stuck? Right? And so I want to show you the process is exactly the same. If you understand the process, the numbers are kind of irrelevant. You understand the process, and if you do the process right, you're going to always get the right answer. Does that make sense? Okay, so I'll stop recording here. I just want to answer questions for you, all that are here, on any topics or issues that you might be having. I don't want to make this video so long, so if you guys want to rewatch this when you're at home, it's not that long of a video, okay? So let me stop recording.